Okay, class 9 students. Now today we are going to start new chapter sound. Actually in class 9 physics you might have got the idea of work energy power, and we have solved many numericals also, or some of the numericals you are still solving. So today let us start a new chapter, that is sound, last chapter of class 9 physics, and then we were doing chemistry also, last chapter, last topic. So we are going to finish syllabus very soon, within maybe 1 or 2 weeks. But that is very important topic, sound wave. This is very important topic in class 9, sound wave or sound. What is sound? Actually sound is a wave, is a form of wave, or we can say a form of energy. But if sound is a wave, then what is wave? We should ask the question, what is actually a wave? Is wave a form of energy? Or what are the characteristics of wave? Frequency, wavelength, amplitude, time period, speed of wave, all these are characteristics of wave. Different types of wave like electromagnetic wave, mechanical wave, matter waves, all these are very important to understand. Different types of wave, and maybe um, the mechanical wave also two types: longitudinal wave, uh, transverse wave. What are longitudinal wave? What are transverse wave? What are different examples of this transverse and longitudinal wave? All these things we have to understand in detail. So today we are going to start a very fresh chapter in class 9, and that chapter is actually the last chapter of class 9, and that is called sound wave. Actually, why sound is called a wave? First we should define the wave, and then sound wave also. So we will start the definition of wave. What is a wave? Actually, wave is a form of disturbance. Wave is a form of disturbance. So, what is the meaning disturbance? Disturbance means that could carry energy also. So we can say wave is a form of energy. So disturbance is also a form of energy because it carries some energy. So before going through the definition part of wave, we should understand, if we are throwing a stone, maybe we have got a stone, and that stone we are throwing in a pond. That pond is very calm, cool, surface is not disturbed. So what we see, that surface which is calm, when we are throwing a stone somewhere, then from that place we are putting some energy. When we are throwing a stone, we are putting energy with the stone at any point, but that energy creates disturbance there, and what we see a few seconds the ripples, we call it ripples wave. So this wave or ripples generated how? Because the disturbance moves from one point to another point with the help of particle motion, with the help of the particles motion. The motion of the particles, what we see, up and down, and wave moves from one point to other point. So that is actually the primary definition of wave, and very important definition also. Wave is a form of disturbance which travels from one point to another point from one point to another point in the medium here in the stone case, what is the medium? Medium is water. By periodic vibrations of the medium particle So here some important points are there. First, wave, that means a form of disturbance. All the disturbance are not wave, but those disturbance which can travel from one point to another point, that in the medium and involves the medium particles. Medium particles perform vibrations, then we call it that disturbance as wave. The disturbance as wave. General picture, common sense picture of wave is like this. Like this, we call it wave. Like this, we call it wave. But this wave actually, that is waveform. What we see, what we observe, that is waveform. But what is the purpose of this waveform? What is the purpose of this waveform? To carry energy from one point where we have put the stone, thrown the stone, to another point. That is actually the purpose of wave. That is very important. We can give example. When we throw a stone, in the pond, then the disturbance travels from one point to another point in the pond. And constitutes a wave. We can call it water wave because water is involved. During earthquakes, seismic waves are generated. During earthquakes, seismic waves are generated. The seismic waves, actually earthquake waves, due to which there could be devastation if a powerful earthquake is there. When we pluck a string, of guitar, then waves are generated. Then the vibration of a string cause the sound wave to produce. Light carries energy from sun to earth with the help of electromagnetic wave. With the idea of electromagnetic wave. Electromagnetic wave, which does not require the medium particles, does not require any medium for propagation. For propagation. So there could be different examples. Sound, we get sensation of sound with the help of sound wave. With the help of sound wave, which carries energy from one place, from the speaker to audience. Speaker to audience. So these are some of the examples what the wave could do. Actually, wave can do numerous things. The energy propagation in the nature is through wave. So in brief, we can say the energy propagation in the nature is with the help of wave only. Either light wave, sound wave, electromagnetic wave, or any type of wave. So now we will go through the types of wave. Types of wave, mainly we can say three types are there. First type is actually mechanical wave. Second type we can say it is electromagnetic wave, that is non-mechanical wave. And third type is matter waves. So if we are going through mechanical waves also, that is our main topic. Two types: longitudinal wave and second is transverse wave. Electromagnetic wave also different types: X-ray, heat waves, gamma rays, ultraviolet, and maybe radio waves. All these are type of electromagnetic waves. And matter waves are a different type. It is associated with material particles. It is associated with material particles. Electromagnetic wave does not need any medium for propagation. Does not need any medium for propagation. Any medium for propagation. Best example is light wave. So we can say different types, but mainly we will focus Longitudinal wave, that is sound wave, and first we will got definition of longitudinal wave and transverse wave, and then we will go through some other topics. First, how longitudinal wave propagates, how transverse wave propagates, what is longitudinal wave, what is transverse wave. So first go through the definition of longitudinal wave. Longitudinal wave is that wave longitudinal wave is that wave in which medium particles vibrate to and fro along the direction of the propagation of wave. Along the direction of propagation. Best example is sound wave. In air or inside liquid. So sound wave in air or inside liquid is actually the example of this longitudinal wave. We will get the detailed idea of propagation of longitudinal wave, how it propagates through compression, rarefaction. First we go through the definition of transverse wave. In transverse wave, wave moves forward, but particles vibrate up and down, perpendicular to the direction of propagation. That is difference between longitudinal wave and transverse wave. Transverse wave is that wave in which medium particle vibrate up and down to the direction of or propagation of wave. In transverse wave, crest and trough are created. Crest and troughs are created. So we will study in detail the propagation of transverse wave, what is crest, what is trough, and also the propagation of longitudinal wave separately. Okay, students, thank you for